Okay, example 7. Let's go through it together. A gardener has 16 meters of fencing to section off a rectangular area of 15 square meters. Determine the constraints on the dimensions of the rectangle and find the dimensions of the rectangle. Now the tip here, determine the constraints, means write an inequality for the values. Okay, we've seen that before. Now the first step here, we know it's 16 meters of fencing, so we know the total perimeter will be 16. Okay. Now the perimeter, it's a rectangle, so the length plus the width times 2 should equal 16. Okay. Therefore, the length plus the width would equal 8. Okay. Length plus width equals 16 divided by 2 equals 8. Now, if we've got to put these in terms of x. So we're going to let the width equal x. You could have done the length, but we're going to do the width equal x. Then the length equals x minus 1. Right. So if you put that in there, you'll get the length is 8 minus x. Okay, so we're good to here. And now we're looking at the constraints, because it said here, determine the constraints. Well, the first constraint is x must be greater than 0, which means we're saying that the width has to have a width. If x was less than 0, or even 0, we wouldn't have a rectangle, we'd have a straight line. So that's a constraint. Length and width can only be positive values. Write inequality statements to reflect this. So constraints are written in inequality statements. Constraint 2 is that 8 minus x has also got to be greater than 0. So the length has to be greater than 0, so x has to be less than 8. Okay, and we can write that as x is greater than 0 and less than 8. Okay, so that's within the question, because the question said the perimeter had to be 16. So we come to the constraints to here. Okay, now we start making a quadratic equation. Now we do that because we know the area is 15 square meters, and the area is going to be the length times the width. Well, the width is x in this case. We've given the width as x, so that's the width, and the length is 8 minus x. So we know when we multiply those together, we're going to get the area, which is 15. So that's 8x minus x squared equals 15. We put that in the quadratic form of ax squared plus bx plus c. And here a is 1, b is minus 8, and c is 15. Now calculate the discriminant to see if the equation is factorizable. Okay, we can just use the discriminant. Okay, or you could just look at it and just see if you could factorize it. Okay, you could do that too. So we said a is 1, b is minus 8, and c is 15. Okay, so that matches. B squared minus 4ac is minus 8 squared minus 4. Okay, and then a is 1 and c is 15. Now they say that equals 4. So that's 64 minus 60, and that equals 4. The discriminant is positive, so there'll be two unique solutions. We've seen that in previous exercises. Okay, and there we've actually factorized it. X squared minus 8x plus 15 equals x minus 3 and x minus 5. Now you could have done that up here. You didn't need to do the discriminant, but it's a nice step and good practice. You could have just gone directly and factorized this. Okay, remember the factors, the two numbers that multiplied together give 15 and added together are going to give minus 8. That's how we would have solved that there. Okay. Okay, so we know then, and be careful here, once that's just factorizing it, then we have to solve it. Solve is x minus 3 equals 0, therefore x equals 3. And x minus 5 equals 0, therefore the other x value is 5. Remember, that's the null factor law. Both values 3 and 5 satisfy x has got to be greater than 0 and less than 8. When x equals 3, the width equals 3, because we define that, and the length would equal 5, 8 minus 3. And when x equals 5, okay, the length is going to be 8 minus 5, and that's 3. So the dimensions of the rectangle are 3 meters by 5 meters. Well done.